Turing machine versus a DFA. So both are deterministic, but in Turing machine there is no need to mention all of the input alphabets. Also, Turing machine is more powerful since it's using context-free grammar instead of a regular grammar like a DFA. So let's start with an example of a Turing machine. Here is an example for a subtraction process that we are going to perform with the help of a Turing machine, and for this subtraction process we have taken M and N alphabets as input strings, and we are going to subtract N from M on the basis of these three conditions, where M is greater than N, M is equals to N, and M is less than N. So here I have taken 3 M's and 2 N's, and I have separated these M's and N's with the help of a 0 here. And as we know that in the starting and in the ending there is blanks available in the tape of a Turing machine. At the left and rightmost side of the tape we will find blanks. So there are blanks for the same reason. So let's start with our first condition where M is greater than N. So here I have taken the same 3 M's and 2 N's. So what our task is, we are going to subtract N with these M's. Alright. So as we understood, there are 3 M's and 2 N's. So the resultant will be must be a single M, where 3 M's are going to subtract 2 N's. So there should be 1 M remaining in the end of or in the output of this Turing machine. So let's see how it is working. So here we are starting from the left side. So in Turing machine we can start either from left or right, it doesn't matter, but here we are starting from the left side of the tape. So we have replaced the first M that we find out in the tape with blank, because here we are subtracting. So here we do not want the values in the tape, instead we want to subtract or empty this tape, and we only want the remaining alphabet as per the condition that we got here, which is M is greater than N. Alright, so we replace the first M into blank and we move towards where? Right. Here is the notation, and we will be leaving whatever comes in the way, either it is M, right, either it is M, N or 0 as it is, and we will be moving towards right. Upon reaching the rightmost blank, we will leave this blank as it is and we would move towards the left, and we would be replacing the first N that we would be finding out upon reaching towards left from the rightmost blank. We will be converting the first N into what? Blank. Here we have successfully replaced the first N into blank. Then we would be moving towards where? Left. It means here. Alright. So again we will be leaving whatever comes in the way, either M, N or 0 as it is, upon moving towards left. And upon reaching the leftmost blank, we start moving towards where? Right. And upon reaching right, we would be converting the first M again into what? Blank. Then we will again repeat the same process. Again we reach there and we will be converting the first N into what? Blank. So here we have successfully subtracted the available number of N's from M's. So again we move towards left, leaving everything as it is. Here, leaving everything as it is. Again we would reach towards the leftmost blank, and again we would start moving towards right, and again we would be replacing the first M into what? Blank. So here we have converted the last m into blank as well as per the condition or the logic that we have designed for this specific Turing machine, and again we would be leaving everything as it is. Again we are at the rightmost blank, and upon reaching the rightmost blank we again start moving towards where left. But here at this stage, upon reaching towards the left end of the tape, we find what? N. Oh sorry, we find what? A 0. So here I am replacing this 0 with what? M, because as per the condition where I have taken 3 m's and 2 n's, I should be remained with a single m. So I have converted all the m's here into b, but still I need a m in the end. So here what I have done, I have replaced this 0 into m to get the correct output. So stage 4 would be the final stage for the first condition of this subtraction process. So here we are done with our first condition, and you can check the same Turing machine for different number of n's and m's, and you would get the same output according to the number of m's and n's. All right, so you are required to check it yourself, found out, and let me know what you have found out with the different number of m's and n's. All right, so here we are on the second condition where we have equal number of m's and n's. All right, so here we have taken 2 m's and 2 n's. Sorry. Right, again we would be moving in the same way where we would be replacing the first m into blank, leaving everything as it is. Again upon reaching the rightmost blank, again the first leftmost n into blank, again the rightmost m into blank, and again the leftmost n into blank. Here we are remained with a 0, and here we want to convert this 0 also into a blank, because here we do not want anything in the output because m and n's are equal. Here m is equals to n, 2 minus 2 is equals to 0. So here where we are done with the cycle where we reach the leftmost blank, and we are moving towards right. So upon moving towards right, where every m is already converted into blank, so here we are replacing 0 into what? Blank. We are moving towards where? Right. So this stage 5 would be the final stage for the second condition where m is equals to n. Alright, so for the third condition where m is less than n, so here we already know that number of n's should be remaining in the tape of a Turing machine. So here what we are going to do is we are going to leave the n that we would be having after converting after replacing 0 into blank. We are going to replace the remaining n's into n's. Alright, and then we would be moving towards right. Again upon moving towards right, we would create a self loop of n's, and we are letting the n's to stay as it is, because in this condition we are supposed to get the number of n's in the output of a input string. So let me show you this. This was for the first condition where m was greater than 0. This was for the second condition, for the second, and this was for the third condition, for the first, second, and third. So here let's see it with the help of the Turing tape. So again here, once we convert the first m into blank, the first n into blank, again the second m into blank, the second n into blank, but we are supposed to get the number of n's in the output of this input string, so we would be starting from this transition for the third condition where we have replaced 0 into blank, and we leave the coming n as it is, as while we have replaced the 0 into blank, we move towards right, and upon moving towards right, we let the upcoming n as it is here as it is, and we are moving towards right. And again, if there are more than one n, we are leaving those n's as it is and we are moving towards right. And here we have created the self loop for the third condition, and here we are done with the Turing machine for the process of subtraction of n minus n. Thank you.